Good afternoon, everyone. This is actually the last SD-WAN session at VMware. And I want to introduce my co-speaker, Larry Zucker. He's our great partner from Accenture. Right? We have done some interesting work with him. And at the end, he's going to come up and talk about how his firm has transformed SD-WAN, transformed the enterprise network, and why SD-WAN is a critical piece of the infrastructure. My name is Kangwan Chintamit. You guys can call me Casey. I run basically the solution architect and the system engineering for VeloCloud. Been with the company for about 4 years. And if you guys look at the session title, we are going to be talking about SD-WAN migration. So the marketing team was getting pretty creative, and we're talking about 0 to 60 in 2 seconds. And honestly, I'm not even a car guy, so I have to do some research and trying to figure out what car can actually get from 0 to 60 in 2 seconds. Do you guys know which car it is?
Tesla?
Exactly. So it's a Tesla Roadster, right? And the interesting piece about this is, if you look at Tesla, and this is actually coming out from one of their interviews, is why do they get to that speed, right, in less than 2 seconds that the regular car just cannot do it? It's basically a combination of what they say software engineering and the battery technology, right? But the interesting part is you have this great technology, but as a driver, you also need to be ready. And for those of you guys that maybe own a Tesla, right, or maybe test drove one, you know it drives a little bit differently from a regular car. And I'm like, yeah, I think I can relate to SD-WAN with this. Because if you look here, you have on the left, right? Oh, this great car, look like my car. That, we know how it works. We know how to drive it, right? It's been like that for the last, 25 years? And that's how the WAN technology has been, right? It's pretty simple. We all understood how to actually migrate and install, right? You get a new site, you get a bigger router. What do? You copy the config, you swap the circuit, and now you're up and running. And now when you go to the right, this is SD-WAN. It's driven by software. It works slightly different, right? Because it doesn't depend on just single circuit anymore, right? It could combine multiple circuits, and now you aggregate all the WAN links together and be able to do dynamic traffic steering and a lot of interesting things, right, that can happen. It gives you a way to bring up a site pretty fast, right? We have our partner that can bring up 200 sites a week, right? That's kind of like unheard of with the regular WAN. The last part is the most important, is for longest time, you're going to be doing this mode where you have a mix of sites that have not yet been migrated to SD-WAN and some sites that are already migrated. So you're going to be operating in a mode where you have a mix of the overlay and underlay together, right? So now you have to think through a little bit how you want the migration to happen, because until you move out the site to fully SD-WAN, you want to make sure that you understand how the traffic flow is going to be done and your applications work exactly the way you want. All right, so how many of you guys already attend some SD-WAN sessions here? Can you raise your hand? How many of you guys attend this session as your first SD-WAN session? All right. And okay, so what I'm going to do is I'll go through a basic pretty quickly, right, on the different components. So really there are 3 main components of the solution, right? Starting from the left, this is what we call the orchestrator. But the easiest way to think of this, it is the SD-WAN manager, right? This is where you go in and you get a UI that you can manage, monitor, configure, right, your SD-WAN solution. Very similar to the NSX manager, right? But this is for the WAN. The second part is called the edge, right? So the edge is basically a CPE that now can go into not only at the branch and your data center locations, because when you move the workload to the cloud, like AWS and Azure, you can also put another SD-WAN edge in there as a software, right? So now, there are more places that you can actually install your WAN edge, right? Not only like restricted to your branch offices and data center anymore. And then the middle part is actually the brain of the solution, right? It's the gateway and the controller. And it actually serves multiple functions, right? One of the functions is it is a controller. Basically take care of taking the route and redistribute it to all the other locations. The other function of the gateway is to do data plane processing for the cloud destination, right? So imagine that you want to send your traffic to Office 365. It's not always possible to put another SD-WAN edge in the cloud, right? Because Microsoft is not going to let you. So what you do is you can take advantage of the gateway service that is available in this case. So now you can use the overlay and get the full benefit of SD-WAN regardless of your destinations. And I'm going to give this to you guys as a reference, right? So you can download this slide later on. We need to understand what are the protocols and ports, right, used by the solution. So that way, one of the considerations that you need to have is when you work with your security team, that's the first thing you need to tell them, right? That these are the ports that I need to have open so the solution can work, right? But basically, there are two main ports. UDP 2426 that we use for the tunnel, and then we have the TCP 443, which is the HTTPS that we use for management. And then don't forget DNS and NTP. So now, this is the architecture, right? There are different ways of how you can insert the SD-WAN devices in your network. Start from, I don't know if you guys can see, start from the top left, right? This is actually the easiest way if you have an existing CE device, right, or existing router, and you are not ready to get rid of it, and you want to put in SD-WAN there, right? And you have the layer 2 switch on the LAN side. We're basically going to do VRP, right, with your existing CE router or the CPE that you have. So basically, we're going to advertise a higher priority in the VRP group, so we become the SD-WAN edge, actually become the default gateway when the overlay is up and running. And the beauty of that is, if the overlay goes down or the device fails, right, for whatever reason, then the traffic can fall back to the CE router, right? So that's one way of how you can design the site. Second option, it's basically, let's say if you have a layer 3 device at the branch, you can kind of hang the SD-WAN edge, right, off the layer 3 switch, and you can use the routing protocol to attract the traffic to the overlay. And when the device goes away, the traffic fall back to the CE router, right? So you can use it as part of your migration, and we do that a lot in the POC, right? Because if something goes wrong, there's nothing that you need to remove. Then you have the other two that we call basically the CE replacement, right? One of the questions that we hear a lot is, I want to get rid of my router eventually because I will get my Ethernet drop and I don't need that T1 interface anymore, right? Can you guys replace the CE router that I have today? Absolutely, right? So what we're going to do is, I want to distinguish between the two, where you do a CE replacement, but you have a hybrid site, meaning that you have an MPLS and you have some internet links. I want to differentiate it from the internet only, right, which is what you see at the bottom left, because there's some different consideration in terms of how you want to have your traffic flow during the migration. And then, of course, you have the case where there's a router only. We put it in there just to remind everyone that, hey, for the longest time, you're going to be operating where you want your SD-WAN site to actually communicate directly or be able to communicate with this site that you haven't migrated to SD-WAN yet. So moving to the right, and this is actually in the DC or in the regional hub, and you see that we normally will insert somewhere in between the DMZ and the core switch, right? So that's why you can actually build the overlay out over the internet, and that's why your security team has to be involved in making sure the ports are open. Some customers also have another firewall here, right? They will also have to open up the same UDP port, so we can build an overlay this way, right? And you also see that at the DC, we generally insert the device somewhat off path. So that way, for the same reason, right? If you don't bring up the branch, this device can just sitting there doing nothing. So let me pause here, see if you guys have any question before I continue. All right, is this clear so far? All right, great. So what is the typical migration workflow, right? So generally, the first thing you have to get ready is the infrastructure. Make sure you get your VCO, the orchestrator account, right? If you use the hosted components from VMware VeloCloud, basically the VCO can be hosted. The gateways, the controller can be hosted by VeloCloud and VMware. Or you can actually deploy everything on premise, right? But the first thing you need to make sure is the infrastructure is ready. And then you're basically working on the traffic flow that you want to have happen. Then the second thing you do is you can activate the hub, right? And a lot of time you can easily activate the hub in advance, right? Basically, and I have an example of what that will look like later on in the slide. But I mean, the idea is you can actually have the hub activated. It talks to the controller. It starts actually collecting the data, like routing table, right, that you have in your enterprise. So before you actually cut over the site at the branch, you already have the hub up and running and ready to go. So there are really two camps, right, when it comes to communicating from the SD-WAN domain to a non-SD-WAN domain, right? And this is going to be the mode that most enterprises are going to be operating until all the sites are cut over to SD-WAN. So typically, I mean, and I get asked a lot, okay, what is the decision to do the one on the left or the one on the right? Right? So the one on the left is basically, we use the concept of what is called a transit site, right? If you work with, or if you're looking at other SD-WAN players, right, it's going to come up a lot as well, that you will designate one or more sites, and typically it's the hub, right, or your data center as a transit. So basically, all the SD-WAN sites are going to backhaul all the traffic toward the non-SD-WAN site or the legacy site through the transit site, and then get back out onto MPLS to reach the site that have not yet been migrated. The drawback with this approach is depending on your applications, right, and your latency requirement, it can introduce additional latency, right, depending on how far away your hubs are from your branch. And I have customers that have 10,000 sites, right, but they are basically domestic in the US. So for them, doing this option on the left is not a problem, right? They can tolerate latency, and they don't have a lot of branch-to-branch traffic. On the other hand, I have a 50-site customer that are global. And for them, backhauling the traffic across continent to the DC, just not going to work. So they would prefer the one on the right, which means that for any site that is a hybrid SD-WAN site, meaning that you have an MPLS link available, you want that traffic that go toward the legacy site or the non-SD-WAN site on MPLS to take that MPLS link directly, right? And you want to do that, as simplest as possible, as you can. And then if whatever reason that MPLS link goes down, you can still use the hub as a backup for transit, right? So these are basically the two approaches that we have seen the customer doing. So before I go into the problem statement of why mixing the overlay and underlay is difficult and how do we overcome it, I'll talk a little bit about how the SD-WAN routing, this is more specific to VeloCloud, but in general, if you look around and look at other vendors, it very much similar concept. So we have a controller, and you have the controller, which is what I'm showing, the gateways, right? Or a global network of gateways that we have. If you put it in your network, you have like redundant gateways or redundant controllers. And then it basically, all the SD-WAN edge will be an overlay between them and basically exchange all the routes in SD-WAN domain through this controller. Right? So for those of you networking guys, right, the easiest way to think of the controller, it performs a similar function of the BGP route reflector. Right? So take the route, send it to all the other guys in the same enterprise. Then you have basically the edge of SD-WAN that you could be running the traditional routing protocol with the rest of your network, right? BGP, OSPF. So the SD-WAN edge, all it does is automatically redistribute the traditional routing protocol that it learns into the overlay. And then it actually, all the edge on the other side can redistribute it back into the traditional routing protocol. So what we also do is, in order to keep or maintain the information that you have in the routing protocol, like BGP metrics, right? Community, local pref, MET, AS path, we do preserve all that information across the overlay. Right? So that way you don't lose your information. And if you're already familiar with using BGP to control your routing policy, it will continue to work exact same way. So now let's talk about the problem statement of why mixing the overlay and underlay are bad, right? I call it a problem of 1,000 doors. It's kind of like you have a house. Normally you have only a few doors, right? Like your front door and your garage. It's pretty easy to figure out which way you get in and out of the house. And then all of a sudden you have 100 or 1,000 doors. And now how do you control which way you get in, which way you go out? So the problem here is if you look at, in this example, it's only 3 sites, right? You have a hub and you have this prefix, 10,000. And you start with these 2 branches that you have not yet you haven't activated yet, right? So the hub has basically a connectivity to the controller. It also has BGP peering with MPLS network, right? So now it actually injects this or advertise this prefix that is in its own network into MPLS. So now this legacy site knows, right, how to get to 10,000. Then you activate your first branch. Now the overlay is formed, right? So you have an overlay between these 2. This branch also knows, oh, I can get to 10,000, right? Because I learned it from the overlay. And because I have BGP running, I'm going to advertise it into MPLS as well. So now this guy now have 2 destinations for the same prefix. You add the 3rd site, now you have 3. So imagine you have 500 locations, and just one prefix alone, you will have 500 destinations, right? So this is becoming a problem. So how do you solve it? So the way you solve it is you want to prevent the branch from becoming a transit, right? And you do that by blocking the redistribution between what you learn from the overlay from getting re-injected back into MPLS at the branch, and vice versa. So how you do that in the traditional world, like in the WAN router today? Anyone? You do a route map, right? But you need to start filtering the routes. And if you do that manually on every site, you can have a big headache with your migration. Just hope that you don't make a mess with your route map and you know exactly all the prefixes that belong to a site. So what we're doing is we're doing some trick with BGP, and hopefully we can make your life easier. So what are we trying to accomplish, right? So the two things we're trying to do here. One is, how do I automatically stop a site, a hybrid site, from becoming a transit, right? Generally, you want to stop the branch from becoming a transit unnecessarily. The second thing is, how do I actually tell my SD-WAN edge which prefixes belong or originate locally at the site? So I can make a distinction between the prefixes that I learn from a layer 3 switch that is local to my site from the prefixes that the SD-WAN edge learn from the remote site, maybe from the underlay MPLS. And so we first came up with this concept called uplink neighbor, right? So what is an uplink neighbor? I like to think of it as it's like a neighbor that you and I have, but we don't like them, right? So it's like we never invite them to a party. They ask us for a favor, we just ignore it. So it's the same thing. So what we do is we will mark the neighbor that will get us in and out of the branch. And typically, this is the neighbor that is the exit and entry point into the remote site, right? So this guy is basically is the entry and exit point into MPLS. And I mark him as uplink neighbor. This guy is local to my site, right? It's a layer 3 switch that I'm running routing protocol with. So I will not mark it an uplink neighbor. So now by default, we enforce this behavior that anything that you learn from the uplink neighbor will never be redistributed into the overlay. It will be installed in the edge routing table. So the edge will actually know that I can get to a legacy prefixes that's sitting here through the underlay, but it will not inject or redistribute into the overlay so that it will not become a transit, right? And then vice versa, meaning that anything that the edge learn from the overlay get installed into the routing table, but do not be redistributed into the underlay. Make sense so far? All right. So now you have another thing that we need to introduce is the concept of what we call the uplink community. So the difference between the two is, in this case, it's very easy for me to mark this guy an entry and exit, right? So I can easily make him an uplink neighbor because it's the only way in and out of the branch. But if I handing my SD-WAN edge off path, right? Basically, remember the second branch design that I showed earlier? So now you have only one BGP neighbor, but this BGP neighbor can actually learn the prefixes from the uplink CE, and at the same time can also learn the prefixes from the LAN side. So I can't just make him an uplink neighbor, right? Because meaning that now I will not even inject this LAN into the overlay. So what I do is we introduce a concept called uplink community. So the way it works is we can easily mark anything that you learn or the layer 3 switch learn from the CE. We can actually set up basically, on your Juniper or a Cisco router or layer 3 switch, set up a BGP route map, match all the traffic that are coming from this guy, set it with an uplink community. Now automatically when it arrives at the edge, if the uplink community matches what you specify here, and we do take both the decimal and the colon notation, right? So if the uplink community match, it's basically handled exact same way as the prefixes that you learn from the uplink neighbor, which means it will not be re-injected into the overlay. Again, stop him from becoming a transit. So now, what is the goal, right? And what are we able to achieve with this approach? Number one, I don't have to go through all this sophisticated config or route map to stop my branch from becoming a transit. It's just a checkbox that you need to do. Uplink can also tell the SD-WAN edge some very interesting information, which is what are the prefixes that are local to the site. Because anything that you learn from an uplink neighbor or anything that marked with uplink community, we know it's not local, right? Because you learn it from either from the underlay MPLS, you learn it from DCI, it's not local to this site. So the default behavior that we actually enforce in the product is as follow. So if I'm learning the prefix, right, from other SD-WAN site, and it's actually the prefix belong to the other SD-WAN site, I'm going to send the traffic to the overlay. Because I know, right? I mean, that site actually owns the prefix and it runs SD-WAN. Let's use the overlay because that's what we want to take advantage of. If I have a prefix that doesn't have any owner, right? Meaning that all the SD-WAN site learn this prefix, and it actually either learn from uplink neighbor or attack with uplink community. Then the SD-WAN overlay knows, actually there's no owner, so it must be a legacy site. So if I learn those prefixes that attack with uplink from the MPLS underlay, I can actually just send it directly to the underlay. And then the last is, if I don't learn, if I'm a branch that either doesn't have a BGP peering, right, on MPLS, or if it is an internet only, I'm going to send it through my hub if the hub actually see that prefix and there's no owner. So now, as you can see that, I mean, if you want to go back to the other slide that I show the behavior. This. We are able to achieve, sorry about that. We are able to achieve both models without much configuration, right? It's basically marking with an uplink or marking with an uplink community. If you don't want any traffic to take the underlay MPLS directly, you don't even need, basically you just don't run BGP at the branch. Right? And if you want the traffic to actually follow the underlay to get to the legacy site, you turn on BGP and you mark it appropriately. Now your problem is solved, right? You no need to do all this crazy BGP and route map configuration. All right, make sense so far?
Yep.
Okay. So let me show you an example. Hopefully it becomes more clear what we are trying to do. All right, too much animation. Okay, so let's look at some example. We've seen this kind of network quite a bit, right? And I'm just like simplify it. So you have two DCs. DC1 and DC2, they're connected using DCI. Then you also have the branch, and this branch is actually a hybrid site, right? Meaning that it has connectivity to MPLS. And eventually, my customer want to get rid of this router, right? We want to replace it completely with SD-WAN. And they happen to run BGP everywhere. All right. So now what do? I mean, you basically you connect the first hub, VCE, right? You connect it to the core switch, and then to the DMZ firewall. Now you activate it. It builds an overlay to the controller, right? Which is in this case, it is hosted in the cloud. And we actually can turn on BGP here. And what we ask folks to do is perhaps just do a route map, right, or filter on the SD-WAN edge until you're ready. But allow the SD-WAN edge to learn the traffic inbound, right? So that's how we can start learning about the prefixes, the route table that you have going on in your customer network or in your own network, and just sit there doing nothing. Now you activate the second hub, right? Same thing. At this point, it hasn't done anything other than just learning the routes. All right, so now we have the branch. So you activate the branch. And now when you turn on the VPN, it will automatically build an overlay, right, between these three sites, right, as well as you notice that I'm actually disable BGP on here because I'm doing the more simplified cutover in this case, right, that the VCE becomes the default gateway. So basically, if you start running BGP with the LAN switch at the site, we're also running BGP with the CE router that is going to be replaced eventually. So where do you think we need to mark the neighbor as uplink? Where's the uplink neighbor in this case? The CE router, right? So this is your uplink neighbor. This is also you running uplink community with the prefixes that you learn from here, and from here, right? So now let's take a look at what is happening at the DC. So by marking the uplink community, now what you see is you can now, the SD-WAN edge can actually differentiate between the green and the blue. And the green here is actually the prefixes that originate locally in this DC. So that's why we're not going to mark it with uplink community. But at the same time, this switch also learning prefixes coming from MPLS network, right? Like the legacy site prefix. So what do you do here? You mark this with uplink community. It's also going to learn prefixes that may be coming from over the DCI, also going to be marked as uplink community. Now this guy is going to be able to differentiate the prefixes that originate locally at the site from the prefixes that it learns from the remote locations. Right? So now it's going to tell the SD-WAN overlay or the rest of the network that, hey, the one in green, I own it, right? I own the one in green. And now, because you connect the branch, you won't be able to see because it's right here to the left, the branch actually learns its own local prefix as well. And it's going to start advertising across the overlay. So now that's why you see this dark blue. Right? So this dark blue is actually learned from the overlay. And because you're running BGP here, these prefixes are going back out into MPLS as well, which is exactly what you need. Why? Because you want this guy to become a backup transit in case the branch MPLS link goes down. You want the branch to be able to actually use internet as an overlay, right? Backhaul the traffic back to this transit site and go back out. The other thing that will happen is because you're also running BGP directly at the branch, right, with the CE router. So now the branch BR1 prefix is advertised or injected into MPLS network. So that's why we want to block it here, because my rule in this case is I don't want my SD-WAN site to relearn the SD-WAN prefix, right, or the prefixes that belong to SD-WAN site across the underlay, right? Or if you want to have a backup, the other way is you can actually do AS-path prepend, so it becomes least preferred, right, from the SD-WAN site perspective. And now at the branch, same thing, right? It's going to learn the legacy prefixes directly from the underlay. It's going to also learn the legacy prefixes coming from the overlay. And remember the rule that we set early on, that because this prefix is tagged with uplink, right? Because it's learning this from an uplink neighbor, the hub, actually when it learns this prefix, it has uplink community set. So now this prefix has no owner. So if we follow the default rule that we put in place in our SD-WAN overlay, this SD-WAN site, this edge actually learn this prefix from the overlay as well as from the hub. So it's by default, it's going to prefer this to get out or communicate with the legacy site. We do the same thing with, this is the SD-WAN site prefixes that owned by DC1 and DC2. We drop it because, hey, we already have redundancy in SD-WAN network, right? Multiple links, multiple hubs. Why do I need to learn it again from the underlay? But if you really want to, have like triple redundancy, you want to make sure that you have AS-path prepend on here. Right, so this is the green prefix, right? And because who owns this? The DC actually owns this prefix. That's why, by default, right, this edge, we actually prefer using the overlay to reach this prefix. Nothing that you need to do. And same thing here, right, that the branch, this is what I showed in the earlier slide, right, that the branch learn BR1, inject it into both MPLS and into the overlay, so the hub will actually get it. And the hub also inject it back, but the beauty of this is BGP loop detection detected, and will basically automatically drop this prefix. So now we are able to achieve, right, this kind of traffic pattern without having to do very crazy configuration, right? You are able to go directly to the legacy site, and if the MPLS goes down, use the hub as a transit to get back out. The traffic between the SD-WAN site automatically prefer the overlay without anything that you guys have to do, special configuration. And now after I'm running this for some time, I'm ready to get rid of my CE router. So all I have to do, remove it, change my BGP neighbor, and I'm done, right? So when I'm ready to get rid of the router, that's all I have to do. So I plan the migration this way because, number one, I'm ready to get rid of the CE router, right? I'm not going to over-engineer the availability that I have. I could have maybe hanging this, the edge a little bit off path, right? And I can take advantage of maybe like when the VC goes down, the traffic fall back to the CE router. But I take a more simpler approach because I'm going to get rid of this CE router anyway and take full advantage of being able to use this uplink neighbor feature and greatly simplify my configuration. Right, so what is the takeaway here, right? The takeaway is, I think, it's just like driving a Tesla, right? You have to kind of learn a little bit of what feature do we put in place to help you guys with migration, which actually evolve around this uplink capability, right? And then once you actually start playing with it and you understand, it's actually a very powerful thing that can really, really save our headache, right, in doing migration and save us from hundreds of lines of configs that you have to do on the router. the traffic flow, right? We have seen a lot where, let's go ahead and cut over a site, right? But I think the most important part is normally the first site is when you run into the most problems. So if you have time or you have a chance, I always recommend that you set up a staging site and test your migration, right? Test your rules before you actually do it on a live site. That way, if you run into or discover any misconfiguration, right, that may already be there even before you do the migration, you catch it in advance. And do not overcomplicate the traffic flow, right? I mean, we are engineers. We want to actually, do some crazy stuff with our network. But ultimately, simpler is better, right? I always look at, okay, if I have to replace the CE anyway, how do I do the configuration so that when I'm ready to pull out that CE, I don't have to go through another set of configuration change across all my site. All right, I think that's all I have. I'm going to ask Larry to come up, right, and talk about all the work that he and Accenture has been doing. And then we have some time definitely left for Q&A at the end. Thank you so much.
Great, thanks, Casey.
Yep.
Do you want to? Great. So my name's Larry Sock. I run growth and strategy for Accenture's infrastructure business. I have all of our solutions and partnerships around private cloud, workplace, service management, and network, but I do have a networking background. And one of the things we've been doing lately is we've actually been pivoting our network business to focus on what we call device to cloud. So how do we do cloud enablement, digital enablement? And as you'll see as I go through that, we're going to kind of walk you through all the network trends that are out there. And you'll see SD-WAN really becomes the glue that ties everything together. So that's what we refer to as device to cloud networking. So I just have two slides that I'm going to walk you through. First, if I take a look at most of our clients, and this includes Accenture, and it seems pretty typical across the industry, but most of our clients are seeing about 30 to 40% bandwidth growth per annum. For Accenture, we're the largest Skype for Business voice and video user on the planet, and it's really driving significant volumes over our global network. But you've got other industries. You go talk to pharmaceutical, it's a combination of collaboration, moving big data around, you look at financial services. So the numbers seems pretty consistent in terms of bandwidth growth. And what most of our clients are looking at is they adopt digital, they move to cloud, they've got these significant pressures on their network. They're trying to figure out ways to cost effectively scale their networks to keep pace with the growing business requirements. So essentially pivot the network from being what has traditionally been a bottleneck of the environment to more of an enabler. And what we see is most of our clients typically have 1 to 10 or there's different network projects that are going on in trying to do this. And this diagram kind of summarizes a lot of those projects. And I'll start right in the center, which is, I think, there we go. And this is something Accenture did a little while ago. Was we had a global MPLS network. We used AVPN, and we were finding that we just couldn't cost effectively scale. We also weren't getting quite the service levels that we wanted. So we essentially built our own Ethernet backbone. We built it in carrier neutral facilities, so the Equinixes of the world, which helped us later was Cloud Interconnect. And then we still use regional MPLS, so we didn't get rid of MPLS. We used like AVPN in North America, Telenor we would use in the Nordics, Telstra, and we got much better price performance. We got better service levels, et cetera. And that what was interesting is we did that pre-SD-WAN. SD-WAN, had SV-WAN being available at the time, we might have re-looked at how we had architected this initially. The next big trend, just being at VMworld, I'm sure you're all familiar with what's been going on in the data centers. So they're using NSX to do the automation. So if you think about it, we were pretty good at provisioning compute and storage. We started to use NSX and overlay technology to do the automation. We then expanded that to micro-segmentation so that we could get a better security profile, protect east-west traffic. So obviously at this conference we've seen a lot on NSX historically and how that's being used. When you start to go out to the sites, Couple things going on there. The first is getting rid of the tethered network, Ethernet. So if I look at any Accenture new office, we don't even put Ethernet. We've got 1 or 2 Ethernet switches and it's all Wi-Fi. So I think, just given how mobile the workforce is now with laptops and tablets and mobile devices, everything's moving over to wireless as being the big trend. And then the real thing that, that KC's been talking about is the implementation of SD-WAN. And the reason SD-WAN is so powerful here is it allows you to basically aggregate multiple circuits. So I can, if I've got an existing MPLS circuit, I may want to keep that for my isosynchronous voice and video traffic, or my business critical stuff and transactional stuff. I can now augment that with a significantly lower cost broadband circuit, so cable, DSL. And then it was the increased use of LTE for wireless local loops, so using 4G, which actually makes it a more diverse environment. So even if I've got 2 circuits coming in from diverse vendors, providers, and there's a fiber cut, they could both potentially go down. LTE gives me a better environment. Now I can, I use my SD-WAN technology, I can steer traffic optimally routed over the correct circuit. So, I might take my voice and video and transactional stuff over MPLS. I can break out and go directly to the internet or route, my email over a slower internet circuit, and then use LTE to load balance. And one of the nice things about SD-WAN, it can also allow me to, hey, if I've got certain caps or financial caps on LTE, I don't want to exceed them, I can take that in there. I can also dynamically route, meaning, hey, I'm starting to have problems on my cable connection. I can now start to, hey, I'm going to move it over to LTE, even though it may cost more, I'm staking a little bit of a penalty. So it gives you a really flexible, highly resilient way to start to cost effectively scale your network. The next big thing is extending to IoT, and there everything's going wireless, whether it's Wi-Fi mesh now. We're starting to see obviously a lot of LTE work. 5G's got incredible promise between, increased bandwidth, lower latency, so it's going to really help in the IoT space. And once again, we see an edge box sitting out there. Over time, 4G now, 5G in the future, but then an SD-WAN overlay that allows me then to connect back, and that's really how it's going to connect what we call, device to cloud, which increasingly will proliferate with the IoT ecosystem. Then moving up into this is the public cloud interconnect. So whether it's going to SaaS like Office 365, ServiceNow, Salesforce.com, or just going into AWS, et cetera, the interconnect. And what's interesting about the first architecture I mentioned, you now have very big pipes and low latency pipes from that network backbone into that environment. So it becomes a very good way to do the interconnect. So this is the net bonds, the express routes, and the interconnects into the Amazon VPCs. The final thing is then extending it to the mobile network, and this takes, you got to partner with the carriers to do this. So they have the ability to do QoS in their network. If you want to go to a mobile device, you can get quality of service if you can then integrate in there. So that's the last real piece to really extend it. Now, what's interesting is we'll go into clients, and they may have 3 or 4 of these projects. They may be doing Wi-Fi and SD-WAN on, at a retail store. They may be doing NSX in the data center as a part of a software-defined data center. They may be doing the VPC interconnect with Amazon, but invariably we find that they're not integrated, meaning they don't have an integrated story. And if you think about IP communications, security and quality of services end to end. Any one piece breaks, you got a security breach, or you have quality of service breaks down with packet loss or performance, the entire chain breaks in IP connectivity. So you really need the ability to align quality of service and security end to end, which is all about policy. So what's interesting is when you look at this and you look at these independently, if the data center guys are doing NSX, the store guys are doing Wi-Fi, there may be a separate WAN team doing the SD-WAN overlay, you've got to start to bring the policy together in an integrated story. And we've been spending a lot of time now focused, and this is some work we're doing with a retailer, and even with a new network architecture, they have Motorola, which are now extreme access points. We're introducing VeloCloud for the SD-WAN to their stores. Within the data center, NSX is providing starting to do the software-defined data center, eventually micro-segmentation. over time will start to go up into Amazon or Azure and that interconnect. But and then they have Palo Alto as a layer 7 firewall. If they're now going to do a mobile point of sales device in their store, they're going to have to go into every one of those engines and configure the security and quality of service policies to do end-to-end. So if that's going to eventually end up going from that mobile point of sales all the way up into, let's say, a serverless architecture in Amazon. So that end-to-end communications and policy integration is an area that we've been focusing a lot on. So Accenture's actually been building with ServiceNow. We're using Ansible. I noticed a red hat over there. Using Ansible to do the provisioning to come into this. Now, one of the things that got us very excited, we were actually working very closely with VeloCloud prior to the acquisition. But one of the things that got us excited about the acquisition is we don't have to do as much of the heavy lifting. So if you look at it now, over time, you'll start to see that policy integration from NSX into Velo so that we don't have to do that load. Because, it's one thing enough to do the provisioning. You then have to keep this stuff in sync, right? I mean, think about firewalls and proliferation of firewall rules. It's exacerbated when you get this device to cloud end-to-end security and quality of service. You need to be able to continue to provision and maintain that. So we've been working very closely with VMware and both the VeloCloud and the NSX teams to see how can they do a lot of the pre-integrated work for us over time that can help with this story. So just, that was it. Just wanted to take you through a quick, show you how we're looking at this device to cloud story. As you can see, going back to the previous chart, you can see SD-WAN becomes the core of this device to cloud. It's really the glue that's going all the way, stretching out to link me into my wireless networks that deal with IoT, bring me into my data centers, and then up into the public cloud. So we've been very excited about the extension of VeloCloud and then the upcoming policy integration that we hope to see over time. Great. So I think we'll open it up for questions.
Any questions? You guys ready to do migration now?
Yeah.
Yeah.
Sorry, what was it? We couldn't.
Actually, I'm glad I'm not a product manager. Right? I think we need to take this to the PM team, and if you want, we can chat later on after the session.
Yeah, I mean, one general comment on IPv6. I mean, we keep introducing technologies that slows it down. I think when MPLS did it, right, for quite some time. I mean, I think SD-WAN will do a little bit of it. I mean, we're seeing it in pockets. I mean, IoT is going to push us there pretty fast when we get a proliferation of devices. Seeing it in Asia where you get address space compression. And typically, I mean, what are the rollout strategies? Like we've done it for large pharmaceutical, where we very compartmentalized rollouts in certain areas, and then starting to expand it more broadly. But I mean, I don't. My personal thing. I mean, I think IoT is going to start to push the envelope, and when we start to get into 5G and IoT devices and autonomous vehicles and stuff like that, I think we're going to have a lot more burning platforms shortly as IoT takes off.
All right.
A real simple question, because at the edge, is redundancy? Is there any HA that you can do at the edge?
Yeah, that's a great question. Actually, I mean, I didn't show it in the slide, but there are actually, I don't know if I have it. There are actually multiple ways to do redundancy. Let's say if you want to do completely SD-WAN, you can actually run it in pair in the HA mode, just like what you do today with dual router. In the data center, we have an option to do cluster, and that allows you to scale horizontally to maybe accommodate thousands and thousands of sites that are coming online.
But by the way, it's somewhat on a related topic. One of our observations is a lot of our clients are actually, they've got little IoT projects in my digital store, my connected mine, and they've got a box that they're putting in for that, and then they're putting in a separate box to run SD-WAN on, and we think that's a mistake. I mean, the whole idea, it's defeating the purpose. I mean, they're essentially building an appliance that looks like, it's just Intel based or ARM based with another appliance. And we're actually trying to encourage them to actually beef up those boxes and maybe even put it like a GPU if they need to, because as you start to roll out the IoT apps, it might be video analytics, so there could be some serious processing happening on that. And a lot of the boxes right now are probably undersized. They barely can run another BNF like a Palo Alto, which will distribute out more if I do the breakout type use cases. So we're actually trying to encourage our clients to put a beefier box out there, with IoT. And the reason I think then you start to look at the HA thing, it gets kind of interesting. But or what you might have is one lower power box and a higher power box and do some kind of HA kind of backup. But when you do have it.
Yes.
So at your branch sites, are you using a specific SD-WAN VNF that speaks back to VeloCloud? What's the requirement on those sites?
Is it question for Larry or from?
Well, I mean, they have an appliance, right, that
Yeah.
they can provide. When we actually deploy them, we prefer not to use the appliance. We actually would put it like on like an edge line or a Dell. I think they still call it VCEs, although they don't. So we, as I mentioned, we're actually going on a little bit bigger boxes and trying to incorporate the IoT applications there. I mean, I think this is a fantastic enabler of IoT because I can start, one of the things in IoT, I want to look at that security paradigm, and I'd like to do the security end to end if I can, right? If I'm going to even bring it all the way up into green, I've got green grass running down here and I want to connect to Amazon mothership, but I want to do local processing. The ability to have that security and quality of service end to end is everything.
Yeah, it's the question about is it like a VNF or is it a physical hardware?
It's
No, yeah, we don't have any specific requirement from our side, right? To like at the branch, we can offer as a hardware appliance, or if you have your own, let's say you already have a server running there, right? And you want to take advantage of the compute that you have, you can basically install the SD-WAN VNF on your ESXi, for example, right? And use it that way. But if you go into like a new site, if you have a retail store with no compute, then it may make more sense to actually ship a hardware, right? Which is like clearly labeled, you know which port to plug it in, very easy to activate, right? Even without any technical personnel on site. So that's one benefit of using the appliance, right? Versus using something like a VNF on a hypervisor. Right, you can do that. If you have a hypervisor, there's a way to push the VNF there, right? And basically have it auto-activate. But it's like a chicken and egg, right? Someone has to put the hypervisor there first. So if it's not already there, it might be a little bit more work. Yes?
Look at the Dell 5000 IoT gateway. Having SD-WAN on their gateway is perfect combination.
Absolutely. And I think that's ultimately where it lives in a lot of our,
Oh.
Yeah, we flipped the room while you were out. That's the power of SD-WAN. It's very flexible.
Dynamic multipath.
We were just trying to confuse the red hat guy. Absolutely, and that's where I was going with it is, we think it's the bigger, a little more horsepower in the box. It might have FPGAs, GPUs over time. One of the big, we're working with one, it was a VeloCloud client. We did not do the deployment with a connected mine. They actually have a Nutanix box out there, separate Velo, deployment. But then they're looking at, we're doing video analytics. We're bringing it up to Azure, but we're not getting enough frames per second up there. So you got to push that down so they're using it for like looking at the teeth on shovels and the tires, which are really expensive when they go down. We're looking at autonomous vehicles, like 8 megabits of bandwidth needed and low latency. So we're starting to see a lot more edge processing use cases, which needs the horsepower. So and that's where I think IoT it goes back to the IPv6 too. I think it's going to drive to the IPv6 use cases as well. But that's where we're really going to stretch the we don't want to get our clients undersizing it. I'm trying to convince them because and you take the store example where you're like, hey, the inclination of the retailers go just dump a cheap device out there, which is being propagated a little bit by service providers, but you may have to revisit the store. They don't look at the aggregate business case because guys looking at the WAN side is basically saying, hey, it's going to cost me this, separate business case for that video analytics, mobile point of sales, and they're not putting it all together that if I hit the store once, I deploy it, I put a headroom in there, I can add another VNF, so if I want to distribute Palo or something out, but then I've also got compute that I can start to do it in. And it's amazing how bifurcated those, I showed you just the different network projects that are bifurcated, but it gets worse when you get into IoT and the business side of it. You meaning, that's what. That's what VMware's great at. That's why they're the right partner there. I'm excited about Pulse and where they're going with that. But Pulse, I take it would be able to, and I can't remember the other tool name, but we'll now be able to manage that environment. And if I take a look at it, I think the whole thing is you'll have different middleware that goes over it. So you think Greengrass, Azure is actually pretty good in the space, and then there's a launch of third-party middleware. But I think there's a huge play to have managed up through the hypervisor, integrated, so storage, network, compute, including like video offload and stuff like that, and then integrated connectivity, which ultimately will be SD-WAN over, in my mind, more of a 5G in the future, or multiple access circuits. So I think it's a huge play for VMware. I think they're perfectly positioned. They have great acquisition here to do this, but you are going to have to then manage that box very closely to figure out, hey, I don't want. Do I really care about, that mobile point of sale better go ahead of that video analytics, right? If I do have resource contention. And it's the same, on the network side, it's been the same problem. We've always had to deal with quality of service, and we've had, the tools have been there for ages, right? To mark, to classify, to queue traffic, to get that. So we've been there. It's always been hard to manage them, but we've had a lot of knobs and levers, and I think this just extends up into the like video analytics and other areas as we start to get more virtualized network functions.
All right. Any more questions? Maybe one last one, if there's any. All right. Thank you all.
Thank you.
Enjoy the rest of the week.